Okay. The ARI working group provides the APIs for CF Uptime Runtime. It provides community clients for end users. The working group is led by Greg Kopp from Broadcom VMware and myself. It's a rather big working group, close to 60 approvers and 20 reviewers, take care for nearly 100 GitHub repositories and 22 areas. And if we look a little bit more inside, we will see the areas. First, there's the CF API, that's the foundation, and together with the command line interface, the CF CLI, and the build packs, that's probably the interfaces that you all know and use on your everyday work. In addition, there are language bindings to the CF API, Java tools, Go tools, and recently also a Terraform provider. And then we have areas that provide, let's say, higher level functionalities and tools like the Autoscaler, MultiApps, notifications to send emails to Cloud Foundry users, and Stratos UI, a Cloud Foundry UI that has been recently re-added again. What we see is a nice growth. We have talked about renaissance of CF, and that's what you can see here. New approvers and reviewers that join the working groups, and yeah, first of all, a warm welcome from my side to these new approvers and reviewers, and of course also a big thank you to all the approvers and contributions to the working group. Because at the end of the day, it's you who ensure that Cloud Foundry is well maintained, is still running, that bugs are fixed, and that new features can be added. Talking about new features. First one, Cloud Native Buildpacks. There's not much to add. We have heard the nice talk and especially the demo. I liked it a lot by Johannes and Ralf. And yeah, the Application Runtime Interfaces working group had its chair here as well. A new CF push strategy has been added. In the very beginning, when you push a new application and update it, it involved a downtime. That was the standard for a long time, and you had to script around it and use CLI plugins to use a blue-green deployment. Then with a V3 API, a rolling strategy was added that allows a zero downtime update of applications. And recently, with this new canary strategy, there is an addition that allows an operator of an application to check after the first instance has been started whether this updated application behaves well by looking at metrics or logs, and then take a conscious decision whether to roll back or to continue the deployment. This feature is available, it's documented, and in addition you have now a max and flight parameter that allows you to update heavily scaled out applications faster than in the past. CF API performance and scaling, that's my major interest in the cloud controller. We have worked a lot to replace the web server that is used in the cloud controller for the CF API from Syn to Puma. Two reasons here. The first one is that Puma is maintained in contrast to the old web server. And the second one is that Puma allows to run multiple cloud controller processes on one VM. And the integration is now finished, and not just the integration itself, but also all the, let's say, second thoughts around it, like rate limits, metrics, train behavior, etc. That's implemented, and it is used in production on all of our SAP foundations that we operate. That means in big landscapes. Puma allows you to cut down the number of cloud controller VMs at least by a factor 2 compared to Syn, because you can run multiple processes on one VM, and CPU and also memory is not that much of a concern on typical VM sizes that you use. So that's a nice side effect, and probably we can even reduce further, but we want to observe that for a while in production and check the metrics. The memory savings were actually achieved by adding an experimental option to switch the memory allocator on the cloud controller to JME alloc. That reduces fragmentation and simply brings down the overall memory consumption, which helps a lot if you run multiple processes on one VM. And finally, brand new, just there since I think 1 or 2 versions of the cloud controller, is connection pool metrics, because that's the next problem. If we think of scale out, then the real problem is not so much CPU, VMs, or horizontal scaling, because that works out well, but it's the number of database connections that you can have to the Cloud Controller database. Another point for scalability is dynamic job priorities. With v3, a lot of the functionality in the Cloud Controller is actually removed from the direct API call into background jobs. That's one of the reasons why the v3 API is a lot faster than v2, but those background jobs need to be processed as well, and we observed issues, for instance, when typically CI pipelines provide a very high load for a single user with lots of background jobs, or if it happens that, for instance, service brokers have an outage and that delays then all the service bindings, etc., background jobs in the past, and we have observed here outages. With dynamic job priorities, also a feature that you have to enable explicitly, a single user, the job priority of jobs that are running for the same user will be reduced the more jobs you have already in your queue, and that allows to spread the jobs on a more fair way between the different users. Helps a lot, prevents outages, enable it. Then, of course, an everlasting theme, database query optimizations. In the last year, service plans, like the year before, and the year before, and the year before. Route destination updates, up usage events, pollable jobs, and much more taking place. And I think that will be the same in the next years as well. And in order to monitor how these optimizations work out, we have added CF API performance tests, more tests, and we reduce the flakiness. And you see here one graph as a result of the route destination update optimization. Looks drastic, but beware, these tests are valid for special use cases where a single application has, for instance, 1,000 routes. That's where you see this performance improvements. If you have just one route, you will probably see nothing, but these are the use cases that we face. Another thing that kept us busy beginning of the year was the movement of the CAPI CI into the community. The pipeline have been moved from a company-specific concourse to the concourse maintained by the Application Runtime Working Group. The bubble environments needed for running the Cloud Foundry acceptance tests also moved into YAS accounts owned by the foundation, and all the secrets and special keys that you need here and there have all moved into the GCP secret manager that allows now all the different contributors and teams to get access to everything and to work and not have to ask around or have certain limits when, let's say, secrets are stored in SAP Vault or in Broadcom password managers, which doesn't work out. So that was a good step into the community. CF-CLI, of course, the new features that have been mentioned need also support in the CF-CLI, so there are additional commands. Cloud Native Buildpacks, small disclaimer, it's just on main, not yet in V8, we heard that. We improved the CLI performance drastically in spaces with many apps, routes, and services. Think of 1,000 and more, where it was very slow. There is a new command line flag to list apps without the process stats, which also increases the speed drastically. If you just want to list all your apps in your space and you have more than 1,000 and want to grab for a name, that helps a lot. There's synchronous task execution by a -wait flag that was simply missing there, and we have Linux ARM64 builds, meanwhile, for the CF-CLI. CF API clients, the CF Java client has meanwhile a nearly complete CF API v3 support for the client API, not this operations API that some people use. Here there are bigger discussions, and it's questionable whether it makes sense to port that to v3, at least one by one. It's not possible easily. There's a new Go client that moved from the Cloud Foundry community into the real Cloud Foundry GitHub organization. It's also based completely on CF API v3, so that's good news. And recently, a Terraform provider for Cloud Foundry was contributed by SAP, which is also based completely on CF API v3 and uses this Go CF client library. So let's have a look at the upcoming features we plan to work on. There are a number of RFCs and features in the queue. We heard Cloud Native Buildpacks as system buildpacks to bring here the feature parity with the standard traditional buildpacks into Cloud Foundry and CF deployment. File-based service bindings is something we are currently working on. The part in the runtime working group has already been implemented, and now the cloud controller part is following, so that we can address this 130K limit in DCAP services that you will hit if you use MTLS for your authentication to, for instance, your databases. User creation by org manager is or addresses a problem that the onboarding of bigger development teams in multi-tenant applications is difficult. Users have to log in once before they can grant it, for instance, space developer role. That is completely impractical for big companies. Generic per root feature should pave the road for new routing features. And for CAPI, we intend to provide a new implementation of the CC workers, which is based on threads, not just on processes, to increase the background jobs throughput by factors. Or on the other side, you could also scale down the CC worker VMs, whatever you prefer. And we intend to enable Puma, the web server, by default, and eventually remove the SYN web server over, let's say, the next year, something like that. And now, my favorite one. CF API v2 end of life. V2, the old CF API, is deprecated since 2021. That's already more than 3 years. It has issues, especially on performance. In our landscapes, we observed that V2 calls, on average, overall, the API is around factor 3 to 5 times slower compared to V3. Such comparisons are always a bit difficult, and you can argue about it, but it's definitely slower and is an issue for the scalability. V2 also blocks, let's say, bigger performance improvements and features that require larger database refactoring. Think of the whole database structure that is responsible for space and org roles, which is a bit problematic and can be improved, but as long as we have V2 here in place, because the database is shared, we are not able to work on that. It's also not tested anymore, by the way, or not deeply anymore. There are unit tests, but cuts don't run anymore in CF deployment, so it's time to say goodbye. And there's currently an RFC that is in its final comment period, hopefully gets accepted in one of the next TOC meetings, and that provides a end game, so to say, for CF API. And no fear, it won't disappear tomorrow. It's a long process. You see here multiple years with TOC checkpoints in between to go the next step. The idea is basically to announce, first of all, an end of life so that everybody gets aware that it will be gone one day. Then we want to change CF deployment in such a way that it is built, tested, and released with disabled V2 by default. Then CF deployment V2 should get removed in such a way that it is by default off, but operators can still re-enable it via an ops file. Then there will be a TOC checkpoint, see how this path went in about 1 year. There is some work to do in the client libraries, finish V3 support, remove V2 from the Java client, think about plugins in CF CLI, and probably more that will come up over the time. And then maybe end of 26, the migration window for third-party clients will then close. Until then, there's still the possibility to use V2 and to think about a migration plan, maybe based on the foundation-owned clients. And then there will be a day and a decision time where we have to say, no, we disable V2 permanently, and that opens then the door that we can remove the code base in Cloud Controller and then think about bigger new features. So with that, thank you very much. That was my talk.